The amperage goes to infinity when I put those two together. Okay, no matter how big it is, it will exceed it. I'm going to show you a pretty funny video with that when I teach you how to use meters. So obviously that's a short circuit. So we need a resistance in the middle to be able to put them together. Right? Now you notice it's not short now, but now we have current flowing through a resistance. We can see that voltage is flowing in, voltage goes into the resistor, and when it comes out, it's zero. So obviously something is happening here. Voltage drops as it goes through a resistor. If we touch this, that gets very hot. So as the electrons flow through it, it's a resistance. A byproduct of that is heat. Okay? Now, there's two rules that go with measuring resistance. One is that we have to shut power off. Number two, disconnect the wires and isolate the item, and we can measure it. And so now we can measure, oops, we can measure that same resistance. All right, so power has to be off, the item needs to be disconnected, and it needs to be isolated to measure resistance. All right, so here is, we talked about resistance going up with certain things. Here is a light bulb. If we measure the resistance of a light bulb, right? It's about 0.8 ohms. Now remember, when you learned Ohm's law, I told you to have this tattooed to your arm. Remember? Okay. So the ohms, which is the R, equals 0.8 ohms. The voltage that's applied to it disconnected again, is 12.08 volts. That means E equals 12.08 volts. If we do this, we're looking for the current that we should have. So I equals 12.08 volts divided by 0.8 ohms. If we do our calculator, we do 12.08 divided by 0.8, and we get 15.1 amps. Now, if you remember before, when we did that light bulb, we ended up, for real, having an I of 1.95 amps. For real. That means that if we do, let's find out what resistance really was. If we do 12.08, we're looking for this, divided by 1.95, we're going to find out what the resistance really is when the system is operating. So we do 12.08 divided by 1.95, and we get 6.19. R equals 6.19 ohms. So what's that say? When this light bulb, this resistance was cold was 0.8 ohms. When it got hot, that became 6.19 ohms. Which means when a resistance goes up in temperature, it goes up in resistance as well, just like the law said. All right, so there was some things over here that goes along with what you learned today. Now, something else. We'll use little light bulbs to show this. All right, we have two light bulbs and we're going to install them in what we call series. Well, we'll use a green wire in the middle. And we'll use a black wire on the bottom. We'll use this big black wire. Right? Notice what happens. They're both lit. If I just do one light bulb, much brighter. But when they're both there, they have to share the voltage. So if we measure the voltage now, because now we have two different resistances in the circuit, right? We start 12 volts. Oh, I'm going to hit. Yeah, there we go. Playing games here. Right, 12 volts. Goes into our first one, 12 volts. Comes out of it at 6 volts. We go into the next one at 6 volts. Then we come out of it with 0. So what happens is the voltage is now split between both of these because they're both about the same resistance. It flows into one, it takes half. The other half goes here and it uses it up the remainder by the time it gets to ground. All right, I want to show you one more thing, and then I think it's a pretty good beginning. up this light bulb. And we have a compass. Okay. Mr. Light bulb is not giving it to us so well. I'll save that for another day. But there is a magnetic field that forms around it. Let's see, if I use a relay. Let's see if I can make a relay do it. I want to give you your money's worth. I'm not explaining how I'm hooking this up, because I don't want to confuse anybody. I don't know if you can hear it, but the relay's clicking because it's activating. And that works on the principles of a magnetic field. So now let's see if I put this over this. Okay, so I'm going to take this off the stand. Bring you over here. Now this is on, this is the relay, and it's magnetized. Now watch the compass. Okay, that's the magnetic field forming around the wires as the magnetic field is created, as electrons flow through. All right, so that is a little bit of lesson to try to bring that stuff together. I don't want to go too long, and I hope you learned something from this. You will have a lesson on using meters and stuff like that, and we'll go into these details a little bit better. Okay, thank you.